Good morning or good afternoon, whichever the case may be, and welcome to this demonstration of ATEasy. This webinar will present ATEasy in a combination of slide presentation and live demonstration, and is intended for those with little or no experience in using ATEasy, or for those who just need a refresher on what ATEasy is all about. I'm going to wait just another half a minute or so for everybody to join us, and then we're going to go ahead and get started. So I'll resume this in about 30 seconds. Right click on their, okay. All right, let's go ahead and get started with this presentation. I'd like to introduce myself. My name is Dale Johnson. I am the Technical Services Manager at GeoTest. Supporting me in the background today is Amit Gadbole, who's going to be answering questions that you present online. If there's any questions you would like to ask, just feel free to type them in to your user panel for the webinar, and Amit will do his best to respond to everybody in a timely manner. Let me start first off with an overview of what we're going to be doing today. So the agenda for this morning is we're going to just do a short overview of ATEasy, what ATEasy is. I'll give a demonstration of how to start ATEasy as an application in your on your system. We will create an application template, which is basically a blank application. We will then go through the process of building an actual application, starting by adding instrument drivers, configuring the instruments for operation, defining tests and the test conditions. We will actually test the program by running it. We'll talk a little bit about some of the debugging functions and features of ATEasy. Once we have a working test program, we will add in a test executive. We will run the test executive, show the report results, and then at the conclusion I'll talk about just a couple of additional utilities that come with ATEasy, and then a summary of ATEasy, and then we'll open the floor for additional questions if there are any. Okay. So start off with an overview, a very simple or quick overview of ATEasy, what ATEasy is. ATEasy is an integrated package that provides test executive and test development capabilities. Test Executive is a utility or an application that comes with ATEasy that provides test execution management and test debug facilities, or UUT debug facilities, that integrates with the test programs that you've developed within ATEasy. This process of execution management and debug is accomplished through three add-on utilities, which are called the Test Executive, which is a driver that you can insert into an ATEasy application. Test Profiles, which is also a driver that can be inserted into an application that allows you to set sequence flow of your test programs, as well as user privilege levels of who has access to the various test programs. And then the Fault Analysis driver, which is an additional add-on package that allows you to create a diagnostics library of the different types of failures you might encounter on testing a UUT, and allowing ATEasy to then guide the operator in a diagnostics and repair process. Combined with those functions is the test development environment. The test development environment allows you to create test programs either in native ATEasy or by incorporating software applications developed on other platforms such as C, Visual Basic, LabVIEW, LabWindows CVI, DLL libraries, and so forth. The integrated development environment is where you create these applications. One of the big differentiators of ATEasy versus other software development platforms is that ATEasy has a predefined structure that is optimized for ATE types of applications. And we'll go through that and revisit that topic or that concept several times throughout the presentation because it's an important one to understand within the context of ATEasy as a development language. Because of the integrated development environment, ATEasy allows for very quick development of your application by imposing or providing a structure for that development. It also makes it easier to maintain and reuse code in future applications. ATEasy has automatic handling of various ATE infrastructure tasks such as evaluating test results, reporting those results to the operator, and so forth. And what it does is it allows the test engineer to focus on testing the UUT as opposed to managing the overall test process. ATEasy is an established test software platform. It was introduced version 1.0 in 1991 and has basically followed the technology development of the Windows operating environment. So as new technologies have become available in the Windows domain, ATEasy has expanded to take advantage of those new technologies, culminating in the release of version 7.0 in 2008. ATEasy is the only software product in the test and measurement industry that has full backwards compatibility between the file formats. So ATEasy 7 application can actually open and use programs that were written using ATEasy 1.0. The only difference or caveat to that statement is that ATEasy 1.0 was ran under a 16-bit operating system. So the drivers for that application developed under 1.0 were 16-bit drivers. If using ATEasy version 7, it is now running under a 32-bit OS, so your drivers need to be upgraded to 32-bit versions of those drivers. But as far as the ATEasy language itself, a version 1 file can open and operate within ATEasy 7.0. And over the years, we've had thousands of applications developed and deployed using ATEasy. Okay, so what I'd like to do now is take you through the process of starting ATEasy. So that process will consist of first creating a unique project folder. We recommend doing this as just part of a general practice when using ATEasy. You don't have to do it, but by creating a unique project folder, it allows you to keep all the files associated with that project in one location, which is much easier for reviewing, using, transporting, and so forth. We'll then launch ATEasy. I'll talk briefly about the licensing options that are available for ATEasy, and then I'll also go through briefly and talk about the help menu and the online documentation available with ATEasy. So let me go back to my desktop and launch ATEasy. And I'm launching ATEasy in a administrator mode. So that it allows me to demonstrate all the capabilities available to ATEasy. When ATEasy starts up, you get this startup dialog that allows you to create applications, to open recently opened applications, work on drivers, open examples, and so forth. I'm not going to go into any of that right now. What I want to go into is the help and go to the About ATEasy. This gives you information about the current version, in this case version 7.0, and build, which is 142B. And it's also from this screen that you can go in and choose the various licensing options that are available to you. And these are a 30-day trial license. You can download ATEasy from our website, install it, and invoke or install the 30-day trial license, and it'll allow you to use the full version of ATEasy for 30 days. At the conclusion of those 30 days, the license will expire. If you'd like to continue that evaluation, you can contact us here at Geotest, and we'll go ahead and grant you an extension to that license so you can continue the evaluation. Once you decide to purchase ATEasy, there's three different permanent licenses that you can use. One is a single user license. The single user license is a software key that allows ATEasy to run on one computer installation. The single license screen is also where you find what we call the computer ID. It's located in the window that I'm highlighting on the screen now. And on occasion, when you ask, for example, a license upgrade, we're going to ask you what the computer ID is. So you can go into the ATEasy help about ATEasy, look at the license under the single license menu selection, and read off or copy that computer ID and send it to us. Other license options, we support network licensing, so you can install a server application on your network server that will allow multiple users of ATEasy to start the application running, and then just request a license from that server, and the server will then manage those licenses and distribute them to users until there are no licenses available, at which point you'd have to wait for somebody to log off before you could then have access to their license. And then finally we have a hardware key. The hardware key allows you to install ATEasy on multiple computer systems, and then whichever system has the hardware key installed on it, either as a parallel key or a USB key, whichever system has that key will then be licensed to run ATEasy. So you can have ATEasy installed in many places, at work, at home, and whichever one has the hardware key installed is the one that would allow development to take place. Also, from the help menu, I want to talk briefly about the online help and documentation. ATEasy comes with a very extensive documentation, online documentation that's available to you. Starting with an introduction to ATEasy. It tells you about the scope and organization of documentation, using online help, quick start guide, and so forth. Goes into a Getting Started guide. The Getting Started guide is a self-paced tutorial that takes you through various exercises of using ATEasy, starting with simple things and advancing to more complex topics such as graphical interfaces, driver creation, and so forth. There's a user's guide that talks about the different functions and features of ATEasy. There's a separate document for the test executive. Which talks about how to use the test executive and customize it for your specific applications. There's a programming reference, talks about the language of ATEasy, the data types that are supported, and then a programming reference on classes, controls, procedures, data types, and so forth. So all of this information is available with the installation of ATEasy. Also, ATEasy has context-sensitive help, so as you're developing your application, if you have a question on a specific ATEasy instruction or statement, you can just put the cursor on that line or that statement, hit the F1 key, and then the ATEasy online help will open up and automatically scroll to that particular topic within the documentation. Okay, I mentioned earlier one of the differentiators of ATEasy is the application structure. So the graphic on the screen now is just a general overview of that structure, consisting of a workspace, which is basically it's a window into your application, a place to organize all the different resources for that application. Those resources consist of a project, which the project is generally targeted towards a specific UUT or family of UUTs. Something that is maybe a family of UUTs has a lot of similarities, very minor differences, so you can use the code for that entire family of UUTs over and over again. Within a project you have three modules. There are the system module, the program module, and the driver module. And these modules are placeholders for the code for performing specific functions within your ATE application. For example, the system module is where you would place code and resources that are used for configuring and controlling your system apart from running tests and making measurements. So anything having to do with, for example, initializing the system, setting up default conditions, a termination process, the code to perform all of those functions would be placed in your system module. The driver module is where you have reusable libraries of code. Typically the driver is code for communicating with an instrument or with various instruments, but can also be apart from instruments. For example, the test executive is a driver that is not targeted to a specific instrument. It's a library of routines that can basically look at your ATEasy application, create a user interface unique for that application, and then provide that user interface to the operator. And finally, the program module is where you would place code or resources specific to testing a UUT. For controlling the instrument to provide stimulus to that UUT, to set up your switching, to route the signals to the various locations, and then to take measurements and perform evaluation on those measurements to determine the pass-fail status. So what we're going to do now is we're going to go back to our live demo and we're going to create an application template. This is basically a blank template for your application. And the process is when you launch ATEasy, or you can select File New or File Startup, we're going to go in and select a new application using the application wizard. You can also create applications manually. That's your choice, whichever you're more comfortable with, but for this demonstration we're going to use the application wizard. And then we're just going to follow the directions for that wizard. We're going to save all of our files to a unique project folder. We're going to create projects, program module, system module. We will not include any driver modules at this point. We'll add those in later, and then we'll save that template. So let me go ahead and jump to my desktop, and I'm going to create a folder for storing my application. And I'm going to go ahead and create a new folder, and I'm going to use a very creative name. We're going to call this folder Demo for storing our demonstration program. And then I'm going to come back to ATEasy. And this is the state that ATEasy was in when I last left it, after we talked about the licensing and the help issues. When you launch ATEasy, this is what you will get. You'll get the startup dialog. Now you can also start that startup dialog as I just did from the File menu. And then select Application using the wizard. So we're going to create a new application using the application wizard. And I'm going to create all my file names I'm going to have as a unique name. And again, we're going to use the creative name called Demo. And I want to make sure that the project location where my various files are stored in is the one that I just created. So I'm going to go to my demo folder on my desktop and select that as my destination for all of my files. So my project file name called demo.prj for project is going to be stored in that demo folder. I'm going to create a new workspace. We'll talk a little bit more about a workspace and what the workspace is in upcoming slides. But I'm going to create a workspace file also called demo. At this point, I can specify what type of application this is going to be. Most applications are test applications where you're creating a test program. Okay. Sometimes you might create an application that is an instrument panel, or another application which might be drivers or something of that nature that is not specific to testing a UUT. And those options are all available to you. In this case, it's going to be a test application, which is the default, and we will not include any of the utility drivers that come with ATEasy, which are the test executive, the profile driver, and the fault analysis driver. So make sure that those boxes are unchecked. Our program file name is going to be demo.prg for program file, again stored in our demo folder. And our system file is going to be called demo as well, stored in our demo folder. Okay, I'm going to choose not to install any drivers. I will install drivers later, but not at this point of the process. And once I click Finish, it gives me then a summary of all of the selections that I made using the wizard. So it's telling me in summary where my workspace file is, what its name is, where my project file and my application is, and the different files that we've created using the wizard. And once I'm satisfied with that, I click on OK. And ATEasy will go through and then create this application template for us. So we now have a template for creating the application consisting of our project, our program module, which is where we would place the code or the resources for making measurements or testing the UT specifically, our system module, which is where we would place code associated with configuring our test system, initializing it, setting up default conditions, terminating the test system at the conclusion of our test process, as well as a folder for drivers, which currently is empty. We don't have any drivers installed in the application yet. So before continuing any further, what I want to do is I want to save this template so that I can come back to it later and continue working on it. Okay, I click on the Save All button, and my application is now saved for future use. All right, having completed all of those tasks, let's talk about the actual application. Okay. The application is going to be a fairly simple one, consisting of the instruments configured in the block diagram that's being shown now. I have a host system, which is where I'm running ATEasy. That host system has a PXI, it's a PXI chassis, so it has a PXI backplane that has plugged into it a GPIB interface, which is connected to a DMM. It has the PXI backplane also has plugged in a relay module and a dual channel programmable power supply. Now, connected to the relays on the relay module, I have some resistors as well as the output of our programmable power supply. So our test process, again, it's fairly simple. We're going to go through and we're going to first test all of the resistors to make certain that they're installed and that they're within a defined tolerance. We're going to take a measurement on those resistors using the DMM. And then we're going to go in and we're going to set up channel A power supply for 3.3 volts, and we're going to take a measurement of that power supply output under various load conditions using our resistors. And then we're going to set up channel B for 5 volts and again take some measurements on that power supply output under various load conditions. So again, it's a fairly simple procedure that we're going to go through, again, to try and keep it within the scope of a 1-hour presentation. So the first thing I'm going to do with my blank template is I'm going to go back and I'm going to add the instrument drivers. Okay, what instrument drivers? I'm going to add instrument drivers for my DMM, which is a GPIB DMM, and that driver, we'll go through the process, show how to do that. I'm going to add an instrument driver for my PXI relay module, as well as an instrument driver for my programmable power supply. Okay. Once we add those drivers in, we'll again save the application just in case there's any catastrophic failures. Now, I'm going to come back for just a moment and revisit this concept of a structured layout as well as the workspace. Okay, this is just another way of looking at the graphic earlier that talked about the structure of an application, showing that the workspace is the container for my application. It's also the window into that application. And then within that workspace you can see that we have a project for creating projects for the different UUTs we're going to test. We have a program module here, which is where we have all of the tests associated with testing the UUT. We have the system module, which contains the code and resources for configuring our system. And we have the driver module, which contains the code and resources for communicating with instruments, as well as any reusable code or libraries of code that we plan to use over and over again. Now, what's the importance of this structure? Basically, the importance of the structure is similar to why you have folders on a hard disk. Right? When you create or install a Windows application, Windows will create folders for documents. It will create folders for music files, for picture files, video files, and another folder for where you would install all of your program applications. The point of doing that is it makes it much easier to then go in and find those types of files in the future. If you want to, for example, use Windows Media Player to play your favorite music, you know that you can go to your My Music folder, open up that folder and find your music and select a audio file to play, and it's very easy to find it, as opposed to having no folders where all of your different files are just put in no order, and then having to wade through that that list of files to find something specific that you want to listen to becomes very difficult. So the structure of an ATEasy application makes it easier to find code as well as easier to reuse code. When you organize your code development and you have a piece of code that you want to reuse, it's very easy to go in and find that code and copy it and paste it into a new application. And the workspace is your window into that application. And we're going to be using the workspace in a moment or two after we look at our drivers, or after we've installed our drivers. And we're going to go ahead and set up or configure those drivers using that workspace. So the workspace is a window into the application. It's a navigation tool that allows you to see the resources in your application as well as go in and access those resources for whatever it is that you need to do. So I'm going to go ahead and go back to my ATEasy demonstration now. And what I'm going to do is install my drivers that we mentioned earlier. So the way you do that is I go to my driver folder. I right click on it and I'm going to say insert driver below. Now this is a predefined driver, one that already exists. I can also create new drivers, which is beyond the scope of this demonstration, so I'm not going to get into that process. I'm going to go ahead and insert a driver, and this is going to be my DMM driver. And you notice when I inserted the driver, I now have a new icon underneath the driver folder for the DMM, and then all of the resources that can be used for controlling that DMM. Okay, I'm going to insert another driver, and in this case it's going to be my relay module, and then finally my last driver is going to be my programmable power supply. So these are the modules for controlling the instruments in our application. The next step that we have to do is we have to configure those drivers. For example, the DMM is a GPIB instrument, so we have to set up the address of that instrument so ATEasy knows what address to use to communicate with the DMM. We also have to tell ATEasy what slot the relay card is installed in and what PXI slot the power supply card is installed in. Okay, so these resources are parameters that are associated with the installation of the driver. And we can set those resources again from our workspace by right-clicking on the driver icon and selecting Properties. So here we have the driver properties for the DMM. First thing we need to do is we need to specify the interface for this DMM, and it's a GPIB interface. So I select GPIB, and when I select the interface, it shows a window that allows me to set the primary address of our instrument. In this case, it's address 16. The next, I need to set up the relay card. Okay, the relay card, I need to specify the slot that the relay is installed in. Okay, again, the interface. In this case, we have none as the selection because this is a PXI instrument, so it's basically a PCI resource to my host computer, so there is no special interface that we need to configure. But I do need to specify the slot location for this instrument, and this instrument happens to be in slot 5. And then with my power supply module, I have to set the slot for that, which is in slot 6. So now we've configured our drivers so that ATEasy knows where or how to communicate with the different instruments that are going into our test application. And again, you can see that it was very simple to configure these drivers using the workspace, which gives me one-click access to the resources of my application, in this case the DMM, the relay card, and the programmable power supply. So I want to go ahead and save my application so all the changes that I've made are kept. And then we'll go back now and talk a little bit more about the application development. Okay, I'm going to take just a moment here, and if there's any questions, give you an opportunity to write those questions out to Amit, and I'll come back in about 15 seconds or so. Actually, I need to cough. My throat's getting a little dry. Okay, we'll continue on with the presentation. Generally, when you develop a test application, you're working off of a document. That document may be prepared by the designer of whatever it is you're testing. It may be prepared by a test engineer who's reviewed the design maybe with the designer or through looking at schematics or other documentation. And what they create is something that we call a test requirements document. This is basically, it's a document that defines the parameters on the UUT that need to be tested, the methodology for testing those parameters or performing the test, and the criteria for evaluating those test results. So for example, paragraph 1.0 here tells us about a power supply test. So the purpose of the test is to validate the operation of each power module prior to connecting it to the UUT. And then for each test, verify the go or the no-go status of the test, and where applicable, report the measured values. So this is one task that we have to do in testing our UUT. There may be other tasks besides just testing the power supply. You may need to perform a kernel CPU test. You may need to perform memory test. You may have analog I/O that needs to be tested, maybe digital I/O that needs to be tested. So all of these different processes or tasks define the overall task of testing your UUT. Each of these individual tasks have one or multiple measurements associated with it. For example, the power supply test shown here has 6 different procedures that you have to go through. Procedure 1 is you're looking for a short on the input, the power input to the UUT. Procedure 2, or test number 2, is looking for a short on the 5-volt input to the UUT. And then we go through and we measure the power supply under various load conditions to make certain that the power supply is working properly. So all of these individual measurements or tests go into the task of testing the power supply. And again, you have multiple tasks associated with testing the UUT. So this whole concept of tasks and tests is something that's duplicated in the structure of ATEasy. Okay, so we come back to that concept of structure again. So ATEasy has this concept of tasks and tests embedded within it. Okay, so by definition, a task is a group of tests that test the same block or logical unit of the UUT, such as a power supply test or a memory test. Okay, an individual test are the programming statements that generate a single result, typically a measurement, which can be evaluated into a status of pass, fail, error, or in some cases no status at all. Okay, so this whole task test structure within ATEasy is there to simplify the process of transposing or transporting the TRD structure to your test program. So if you go back and look at the TRD again, you have these major paragraphs, which are your task, and then you have your subparagraphs, which are the individual tests to perform that task. So ATEasy has the same thing, where you have the task, in this case a power test, and then you have the individual tests for performing that power test. And once your individual tests have been added into the program, ATEasy also facilitates adding in the criteria that are used to evaluate the pass-fail conditions. So again, if you go back and look at our TRD, you can see pass criteria. In this case, a measurement of 33 ohms or less. Or it may be a measurement of 3.1 volts to 3.4 volts. These are the pass-fail criteria from our TRD, and those can be placed into the properties of each individual test within our application. So ATEasy makes it very easy to take that TRD structure and represent it within our individual application. So let's go ahead and do that within our the application that we've been developing. We're going to go in and create several tasks, and within each task we're going to create a number of tests. We're going to define our pass-fail criteria, and then we're going to write the code for performing each of those individual tests. And that code typically involves controlling instruments, making the appropriate measurement, and then storing the results in what we call the test result variable. I'll speak about that a little bit more in the future. And then we'll save the application. So just to revisit our block diagram, the three instruments we have are the DMM, the relay module, and the programmable power supply. So our tasks are going to be, first of all, to test the relays, or excuse me, the resistors, to make certain that they're installed in the proper value. Then we're going to program the power supply A at 3.3 volts and measure the output under various loads, and then power supply B at 5 volts and again measure the output under various loads. So let's go to our ATEasy application and begin this process. First thing I'm going to do is I'm going to select my program module. Okay. And this is where we place all of our tasks and tests. So you notice that when ATEasy first starts up, it gives you one untitled task and one untitled test within that program module. So let's first of all redefine this untitled task as the resistor task. And then we have three tests that we're going to perform underneath this task. We're going to measure the 10 ohm resistor, the 100 ohm resistor, the 1K, and the 10K resistor. So my first test is going to be the 10 ohm test. All right. So this test, we're going to measure a 10 ohm resistor. And what I'm going to do now is I'm going to define the pass-fail criteria. I open the properties for this test. Okay, and we have a test type. In other words, the test type is how ATEasy is going to evaluate the pass-fail criteria. And in this case, we're going to use a tolerance measurement. So the value that I'm looking for in this case is a 10 ohm measurement. Okay, and let's pick ohms down here. And I'm going to take a 10 ohm measurement plus 1 ohm and minus 1 ohm. So it gives me basically a 10% tolerance. And then I go ahead and enter these parameters into my test properties, and you'll see now that those properties are listed in the header underneath for this test. Right. And now I can go in and I can write the code for this particular test. All right. Now the test the code that I'm going to write is going to be using the driver modules that we installed previously. And it's very simple to use those modules just by referencing them by name. For example, the first thing I'm going to do is I'm going to make certain that all of my relays are in a default state. So I type the word relay, indicating that this is the relay driver I'm going to communicate with. I hit the space bar and I want to reset all of my relays. Okay. The next step is I want to set my DMM. Okay, so I'm going to type DMM. I'm going to set, and notice how ATEasy provides me a structured navigation to select the various commands for making my setups and my measurements. I'm going to set the function to volts DC. I'm now going to close a relay, so I'm back to my relay card. And I want to close relay number 1. Excuse me, that's not number 1, it's number 3 from my drawing. It's the 10 ohm relay. And then I'm going back to my DMM and I want to make a measurement. And I'm going to store that measurement into a variable. Now it's given me an option here to use the test result variable. Test result is an internal variable defined within ATEasy, and it's a special case variable. ATEasy will take whatever value you put into the test result variable and it will use that to perform an evaluation of that value against the test properties. In this case, those properties are, I'm evaluating the test result value against my 10 ohm resistor measurement plus 1 ohm or minus 1 ohm. So in essence, if test result comes back to 9 ohms to 11 ohms, that ATEasy will indicate that as a pass, and if it's anything outside of that range, ATEasy will indicate it as a failure. So I'm going to go ahead and take my DMM measurement and assign it to test result and allow ATEasy to perform the evaluation for me. Once the measurement is made, I want to open my relay again to make sure that it goes back into a condition where the relay is are all disabled. So I'm going to go back to relay, and I want to open relay number 3 again. So this is the code for performing the first test of my resistor task, and that is measure the 10 ohm resistor. Okay. I'm going to go ahead and copy this code because I'm going to do something very similar in my next test. So I'm going to go ahead and insert a new test, and we're going to call this the 100 ohm test. I'm going to define my tolerance to be 100 ohms. Again, if I stay with 10%, it's plus 10 and minus 10 ohms for resistance. I'm going to paste the code that I copied previously, and all I have to do now, actually I'm going to pull out my relay reset since I know the relays are already in the proper condition, and I'm going to set open or close relay 4, make a measurement, and then open relay 4. Okay, so you can see how it's very easy to reuse our code just by copying and pasting. I can also copy the entire test and reuse it, and then just redefine the name of the test. It is now a 1K ohm test. I change my evaluation parameters, and I change my relay to relay 5. And we've got our next test, and again I can do the same thing by copying that existing test again and creating a 10K ohm test. And we'll now use resistor or relay 6. Okay. So we finished all of the tests for our first task, which is the resistor measurement task. Okay, now I'm going to go into my and create a new task. I'm going to insert a task after the existing one, and we're going to call this the 3.3 volt power task. And within this task we have 5 tests that we're going to perform. The first one is going to be a no load test. Okay, I'm just going to go ahead and define my structure first, and then we'll go back in and define the properties and the parameters. Okay, so the first one is a no load. The second one is under minimum load. The next one is under nominal load. Fourth one is what I call a heavy load. And then the 5th test will be under maximum load. So for each of these tests, now we're going to use a different test type. We're going to use what's called a min-max test type. I'm going to look for a minimum of 3.2 volts to a maximum of 3.4 volts. And again, my unit of measure in this case is going to be volts. And let me go ahead and write the code. So the first thing I want to do, I know my relays are already in the proper state, so I'm going to go ahead and I'm going to set up my DMM. I'm going to change the function of my DMM I just realized I made a mistake previously. Let me go back and make a change real quick here. All of these resistance measurements functions should not be VDC, they should be 2-wire resistance measurement. So let me change those quickly. I'll copy that new line and paste it. Oh, that's all I need to do. Right there, right here, and right here. Alright, now I can go back, set my voltage measurement to VDC. I now can control my relay. I'm going to close relay number 1, which is channel A of my power supply. I'm now going to take a measurement, again store it into test result. And then I'm going to go back to my relay and open relay number 1 to isolate it from my measurement. Okay. So in this case, we're taking a measurement with just the power supply connected to the DMM. Okay, I'm going to copy this code. Now under minimum load, I'm going to add in another relay statement, and I'm going to bring in my 10k ohm resistor, which is relay number 6. Okay. So this applies a light load on the power supply, and again, the measurement should be within our value of 3.2 to 3.4 volts. Copy this code, and I'm going to use the same code in each of my subsequent tests, but I'm just going to use a different relay in each case for the resistor, and in each case I'm still expecting 3.2 to 3.4 volts. Okay, we're down to our 100 ohm resistor, which is relay 4. And finally, our 10 ohm resistor, which is relay 3. Okay. So now we have our 3.3 volt power task with all the associated tests. And what I'm going to do here, just to shortcut the whole process, is I'm going to copy this task, including all of the tests, and I'm going to paste a copy of that below. And now all I have to do is modify the parameters, such as the name is no longer 3.3, it's a 5.0 volt test. And then all I have to do is change, let's see, change some code in here. Okay. Alright, so under no load, first of all we change this to the min-max from say 4.8 to 5.2. And instead of relay 1, it's going to be relay 2, which is channel B of my power supply. And so all of these I need to make those changes. 4.8, 5.2, relay 2, again 4.8, 5.2, relay 2, 4.8, 5.2, relay 2, and then the last one, 4.8, 5.2, and it's relay 2. Okay. And I'm going to go ahead and save all of my work. Alright, and one other thing I need to do is at the beginning of each of my power tests is I need to set the power supply. So I'm going to go back in and insert a new line of code here. So I'm now dealing with my power supply. So power supply, I want to set channel A voltage to 3.3 volts, and for my power supply I want to set channel A, connect it, the output up. Okay, and then at the very end I want to go back and say, we'll just leave that connected, and after the last test I want to go back for the power supply and set channel A, let's see, connect to be false. So that turns on channel A for 3.3 volts, connects it up, allows us to do the measurements, and at the conclusion we turn that power supply back off to isolate it. And now we're going to do the same thing for my 5 volts. Power supply set channel B voltage to 5.0. Connect it, and then at the conclusion disconnect it. Okay, so we've created our fairly simple test program. Okay, now before actually running the test, let me save it and talk a little bit about some of the debugging features. For example, ATEasy has these toolbars that allow you to check your code for syntax errors. You can check highlighted code, you can check an entire module, or you can check your entire application. There are also tools for setting breakpoints. Okay, you can set breakpoints. You can step into procedures or subroutines. You can execute an entire procedure or subroutine as one step. You can step through that procedure. You can step out of a subroutine to conclude the processing of that subroutine. All of the typical tools that you would find in a fully featured code development platform are available within ATEasy. So when you create your application, first thing you would do is probably want to check the syntax, make sure that all the variables are defined, that you haven't made any typo errors, and then once you start going into testing the program, then you can use breakpoints, you can use watch variables and so forth to aid you in debugging the code in order to get everything working properly. So let me go ahead and do a check on my project and see if there's any errors. Okay, so this comes back and ATEasy informs me I have no syntax errors. So let me go ahead and try and run my application and see what we get for result. Okay. One other property I need to set for my DMM is open on access since it's an external instrument. Save and try that again. Okay, so here's the results of our test. You can see the 10 ohm, 100 ohm, 1K, and 10K tests. The value that we are expecting, in this case the 10 ohm test is 10 ohms plus or minus 1 ohm. We measured 9.971 ohms, so this test passed. Okay, you can see similar results for the 100 ohm, the 1K, and the 10K ohm test. Okay, also then we go down into task number 2, which is our 3.3 volt power task. And we have all the measurements under no load, minimum load, and maximum load, and the same thing for the 5 volt test. So at the conclusion, what we have is a UUT status that says pass. Now this report is being displayed in a text format. I'm going to go ahead and change this around to display it in HTML format. When you display it in HTML, you get the addition of color representation of your test results. So when I run it now, you can see green for pass, and if you had a failure, you would see red for fail. Okay. And when this is all done, you can use this report as a repair ticket. Let's assume you had a failure. If you print this report out, it tells you what test step failed, what the measurement was that the failure occurred with, and then it gives you a line at the bottom to sign where the technician can sign his name, so the whole process is time stamped with the signature and results of your test process. So at this point we have a working test. We've gone through the criteria of defining our tasks, and you saw how we can create tasks that follow the TRD document. For each of the tasks we defined the test, again following the TRD and including in the evaluation parameters for determining pass-fail. We wrote the code for the individual test, and stored the results in test result, which allowed ATEasy to perform the evaluation for us. We ran the test and we got good results. Okay, what's next? Okay, we've already checked the syntax errors. We've run it in the IDE mode. If we had any bugs, we could again use the watch variable, set breakpoints, the step process to step through into and out of procedures, and we could use a function called doit to perform selective code execution. And that's how you develop an application. Now let's include the test executive. Okay, I mentioned earlier that there's a couple of utilities that come with ATEasy, and I can see we're getting a little close to our time limit here, so I'll try and move through this fairly quickly. But what a test executive does is it manages configuration, execution, and flow of the individual tests. ATEasy does this by creating a unique user interface based on your test application. In addition, the test executive provides test program infrastructure such as data logging, managing user privileges, which we won't do in this application. It's kind of beyond the scope of an introductory demonstration. It allows you to manage release and archiving of programs. It provides a standardized production or development user interface, and provides diagnostics and troubleshooting tools for testing the UUT. So all of this is encapsulated in your test executive in this this dotted line. So all of these functions, they sit on top of whatever code you're using to actually perform the test. That code could be ATEasy, it could be LabVIEW, it could be any variation of C programming languages. These different code modules communicate with instrument drivers and switching in order to test the UUT, and all of that is represented to the user in a Windows-based user interface. And that's basically what the ATEasy test executive does. Is it provides your sequencing control through what we call a profile driver. It gives you debug features such as stopping on UUT failures, allowing you to single step through your tasks and your tests, providing selective test execution. Has a customizable user interface. We have two modes for the test executive, what we call a touchscreen mode or the standard monitor mode. I'll briefly go into that in the demonstration. Built-in security features, again with management of user privileges, data logging, and you can integrate the what we call the profile driver for controlling test sequencing, as well as the fault library driver, which provides guided diagnostics and troubleshooting repair processes to your application. So to use the test executive in ATEasy, basically all you have to do is insert the test executive driver. You can then run the application, which will generate a custom user interface for you. You don't have to write any programming code to create that user interface. That user interface allows you to select tests, to set test conditions, review the report log. I'll show you both the standard and the directed user interface. We'll build the application to an executable, and of course we'll save our application. So let's go ahead and run through this process. I'll go back to ATEasy. So we're going to take our existing application, and the only thing we're going to do now is we're going to add the test executive driver. So again, I come down to the last driver in my list. I right click and say insert driver after, and I'm going to go to my test executive driver, which happens to be right here, and install that into our application. Now I haven't written any additional code. This particular driver module is built in such a way that it can actually read the structure of an ATEasy program. That's another advantage of having structure to it, is that you can then write other applications that take advantage of that structure. So our test executive will read the structure of our application. It will create a custom user interface for the tasks and the tests that we defined. So let me go ahead and start the application running. The test executive looks through the structure. Here's our custom user interface with all of our different tasks and tests. You notice we have a checkbox which allows us to select an entire group of tests or an entire task to enable or disable, or you can enable and disable individual tests within the task. You also have toolbars for setting, for example, pause on task failure or test failure, allow you to run through your test process or your test program task by task, test by test, loop on a particular test or task. So all of these different controls for how you want to allow ATEasy or the test executive to run your application. So I'm just going to use the default condition, which is run everything continuous start to finish. I'm going to go ahead and start the application, and again you can see the test results very much like what we saw previously when we were running in the IDE environment. The difference is now that we can take this test program, and using the toolbars we can print the log, we can save the log as a file, we can set up to log only failures and print those out or save those. We can clear the log and do various things with this test log. And again, we didn't have to write any code in order to have this facility for us. That infrastructure was built into ATEasy and the Test Executive because ATEasy is optimized for ATE applications. And we understand that one of the things you need to do is you need to report the results of your test program. So the Test Executive gives you that reporting capability built into it without having to write any code. The Test Executive can also work with two other modules, what we call utility modules, one of which is the profile driver. Okay, the profile driver adds the capability of being able to run your selected programs, tasks, and tests in a custom sequence. By default, ATEasy or the Test Executive will run those tasks and those tests in the order in which they were created, but the profile driver allows you to change that order around, put conditions on running your test. So example, if a test in a particular task failed, you can jump out of that task. Don't execute any additional tests within that task. You could abort the program or you could jump to a new task. The profile driver also allows you to associate user levels with the different profiles that are available. So a operator might have the ability only to run go, no-go tests, whereas a technician might have the ability to run diagnostics tests. So the profile driver gives you control of the sequence as well as managing user privilege levels to those different test programs. And finally, the fault library allows the program developer to define fault conditions that can be analyzed by ATEasy, and then you can input instructions to the operator of what to do in those certain fault conditions in order to remedy or fix that fault. So when it's activated at runtime, the operator will actually be prompted to replace assemblies or components based on the failures that are identified as ATEasy or the Test Executive runs through the process. And again, this is all seamless integration with the Test Executive. You don't have to write any code in order to use either the profile driver or the fault library. Okay. So let me go back to my application and finish up one last task. We've demonstrated the Test Executive. Again, if I wanted to, for example, disable all but a particular group of tests, I can do that and run just a subset of my tests, print the report results, and so forth. I want to save this application. Let's go back to ATEasy here. I want to save the application, and I'm going to build an executable. Okay. So I've now created a program called demo.exe, which is located in my demo folder, which will allow me to actually run that application external from the ATEasy environment. Okay. By the way, when you create an application with ATEasy, we don't charge you any royalty or licensing fees to distribute that compiled application. The only licensing fees are for the development installation of ATEasy. So you could create an application and port that to 10 test systems out on your factory floor and not have to worry about paying any additional licensing or royalty in order to do that. So that basically concludes the live demonstration. Just a summary now of ATEasy benefits. ATEasy provides a structured development environment structured towards ATE types of applications. By having that structure, we can provide certain infrastructure such as evaluation of test results, report generation, and so forth that are commonly associated with ATE types of application. Structure also provides easier code maintenance and reuse of your test programs. ATEasy supports Visual Basic-like forms, menus, and controls. It's very easy to learn because it leverages off of a user's current knowledge of Visual Basic. It has a very similar development environment to Visual Visual Basic. In fact, it's a simplified version of Visual Basic language. So again, you have faster development and debug. ATEasy supports language extension through common software languages and tools such as ActiveX libraries, DLLs, COM, and .NET assemblies. So you can leverage your existing code and applications into an ATEasy application, which saves you time and money. But also then you can take advantage of the test executive abilities of ATEasy. So once you port your existing code into an ATEasy application, you can link in the test executive and have a user interface around all of that library of code that you have sitting on your system. The driver, ATEasy is driver and interface independent, so you can design your test programs independent of the underlying system components. This allows for interchangeability of your test programs and your test instruments. It is an open system architecture supporting PCI, compact PCI, PXI, VXI, GPIB, and a host of other interface formats. So you don't have to worry about being locked out of using whatever instruments you might have sitting on your shelf. We integrate configuration management tools such as Visual SourceSafe. And again, we provide royalty-free application deployment of your applications. So we're committed to supporting you, continuing the development of ATEasy. We've invested literally millions of dollars over the last 18 years in the development of ATEasy. It is one of our core product offerings, so it's not going to be going away anytime soon. ATEasy is a mature product. We've got thousands of applications being used worldwide. Again, it's the only product in the test and measurement industry that has maintained full compatibility across the different versions, and we intend to do that with future developments of ATEasy. And we are committed to working with you towards your ultimate success. We do this by incorporating your requested features into future releases of ATEasy, by offering what we believe is outstanding technical support and response time. And part of the excellence in our customer support comes through the use of Magic, which is a web-based support tool for answering any technical questions you might have. And with that, the last thing I want to say in closing before I give you an opportunity for any additional questions is that if you'd like to try out ATEasy, you can go to our website, download ATEasy, and install it on your system and run it using the 30-day trial license. Try the Getting Started manual, which is, again, it's a self-paced tutorial that will take you through the process of learning ATEasy from basic stuff that we demonstrated here today to more complex topics such as graphics and forms and controls, as well as creating drivers and extending the command set of your ATEasy application. With that, I want to thank you for taking the time to be with us today. Whether it's morning, afternoon, or evening, I'd like to wish you a good day and give you a last opportunity to ask any questions. If you have questions that come up later, again, use our online tool called Magic, or feel free to send an email. You can send an email to dalej@geotestinc.com. I'll go through that again. dalej@geotestinc, all one word, and inc is inc.com. So if you think of a question later, feel free to ask, and we'll get you an answer promptly. So with that, we're going to conclude the presentation, and we hope that you'll join us again in the future. When I close this out, you will get a survey asking what you thought about the presentation, as well as an opportunity to suggest future topics. So please take the time to fill that in and tell us what you think and what you'd like to see in the future, and we'll try and incorporate that. So have a good day, and we'll hope to see you all later. Bye-bye.